Alright, this is the second part of the Algebra 2 review. So as you can see, when we have complex fraction, we have to multiply top and bottom by the common denominator. So here we can see the common denominator has to contain 3, 2x, but also 3 squared, which is 9. Then I believe it is 18x. Then what we end up getting is from here, when 18x multiplies to 3, then we have 6x, hence we end up getting 12x squared for the first one. Here we have 9, so plus 27, multiplying that with 3. On the bottom we have 2 is left, 2x with 8x become 2x with the 4x, that becomes 8x squared. And we have x and x cancels out, we have plus 18. And since we see some common factors here, we feel to factor out common factors, we have 3 left with x squared plus 4x squared plus 9. And we have 2 common factor on the denominator, 4x squared plus 9 once again. Then 4x squares cancels out, we end up getting 3 over 2. Alright, how about the bottom one? We can multiply top and bottom by x. And here we have x squared minus 1. And on the bottom we have x plus 1 times x. Now, when we factor out the numerator, we end up getting x plus 1 times x minus 1 all over x plus 1 times x. So x plus 1 cancels out. We end up having x minus 1 over x. That becomes our answer. Alright, let's move on to the next one. What is the solution of this one? So in this case, what we have to do is we have to multiply by common denominator. But if you notice here, x squared plus 4x plus 3 is in fact, when you factor them out, x plus 3 times x plus 1, which ends up being the common denominator for all of them. So therefore, we end up getting, if you multiply this side by this over here on the left side, and this one to the right side, then what we end up getting is x times x plus 1 plus 2 times x plus 3, which is equal to simply 6. So once you distribute, we get x squared plus x plus 2x plus 6 equal to 6. Then this will simplify into x squared plus 3x is equal to 0 by subtracting 6's from both sides. When you factor out x, we will end up getting x times x plus 3 will be equal to 0, where x will be equal to then 0 or negative 3. Now, but we always have to check up on these two values. Notice if you were to plug in negative 3 in place of right here or here, it will make these two fractions undefined. So therefore, negative 3 has to be out. Only possible answer is choice B. Alright, let's look at the same thing here. What should we multiply? That's right, 3x for both sides. Then here we end up having 12, because x's cancels out, and then plus 9 minus 4x, which is equal to, here 3 cancels out, we have x squared. And bring everything onto the other side, we end up having 0 equals x squared plus 4x, and then this one would have been 21, but going over to the other side, we end up getting negative 21. So this will factor out to x plus 7 and x minus 3. Then we'll get to realize that x has to be either negative 7 or 3. So in this case, both of them would have been correct answer. How about number 3? Here, since this factors into a plus 4 and a plus 3. So what we can do is we can multiply both sides by that. And a plus 3. Let me just draw the borderline right here, just so that we know. Now, the other side, likewise, we have to multiply a plus 4 and also a plus 3. And here, the first one, first term, a plus 3 cancels out. We end up having 5 times a plus 4 and minus 3 times a plus 4 cancels out. We have, therefore, a plus 3 equals to 21. Then here we end up having 5a plus 20 minus 3a minus 9 equals 21. Then we get to realize that 2a by subtraction, and this one would have been plus 11 equals 21. Then when you solve this one, 2a must be equal to 10. Therefore, a must be equal to 5. All right. Let us move on to the next question. Here, how are we going to do this? In fact, if you have to move this one to the left side, meaning subtracting 3 from both sides, then we'll end up getting x minus 2 over x plus 4 minus 3 has to be greater than 0. Now, to make that into the same denominator, I'm going to multiply top and bottom by x plus 4 times x plus 4. Then here we end up getting x minus 2 all over x plus 4. But negative 3 times x becomes negative 3x. Negative 3 times 4 becomes minus 12. Has to be greater than 0. Then when you simplify this one will end up being negative 2x and then minus 14 over x plus 4. Has to be greater than 0. Now, when you have the fraction compared to 0, there's two places which we have to look at. One is when the denominator is equal to 0, which is when x equals negative 4. And another place is when the numerator is equal to 0, meaning negative 2x minus 14 has to be equal to 0. That means x will be equal to negative 7. So, from a number line, we have negative 7 and negative 4. So we have three intervals. Let's check upon each and every one. In this case, what if you have to plug in negative 10 as our testing point, testing value? So we can plug it into this place, for example. Then what would have happened? When you plug in negative 10 here, we get 20 minus 14 becomes 6. And the denominator becomes negative 6. So therefore, we end up having negative value. And if you have to plug in the number between negative 7 and the negative 4, what if you have to go for negative 5, for example? So if you have to plug in negative 5, the top portion becomes negative, bottom is also negative, which makes this one to be positive. And if you have to plug in the number above that, such as 0, then we'll end up getting negative value. But in this case, we are looking for positive, so our correct answer will be from here to here. That becomes our answer. So our final answer becomes x has to be greater than negative 7, but less than negative 4. All right, let's move on to the next question. Here, same idea as before. So when we subtract 7 from both sides, we'll end up having x minus 11 over x plus 5, now minus 9. But we will multiply top and bottom by x plus 5 to make the common denominator, and hence making it into one fraction. Has to be greater than 0 because those two cancels out. We end up having x plus 5, and the numerator becomes x minus 11, and then minus 9x minus 45. Has to be greater than 0. Now, then, after simplifying it, we get to realize that negative 8x, then minus 56 over x plus 5 has to be greater than 0. That's simple, greater than or equal to 0, my bad. Alright, that means when you factor out negative 8, we have x plus 7 over x plus 5 has to be greater than or equal to 0. Here you see 2 points where top it becomes 0 is negative 7, where the denominator becomes 0 is negative 5. Now let us test a few other points, such as, how about negative 10? If you have to place negative 10, then top, this portion becomes negative. Negative, negative becomes positive, while denominator is still negative, so it becomes here negative. Between negative 7 through negative 5, let us pick maybe negative 6. Then top is positive times negative. Top, therefore, the entire numerator becomes negative, while the denominator is also negative, so therefore this becomes positive. And if you have to plug in 0, for example, then we'll end up getting negative. And since we are looking for positive or equal to 0, so this will be our solution. The answer is negative 7 to negative 5 for the values of x. Alright, let us try to simplify this one. Here we have 2 square root of 5 and plus 1/2, and then this becomes 2 square root of 5, because square root of 20 is 4 times 5, and then square root of 4 becomes 2. Now minus 1 over 5 times here 3 square root of 5. To rationalize the denominator here, we end up getting multiplied top and bottom by radical 5, and we end up getting 2 radical 5 over 5 plus this 2 cancels out with this 2, radical 5, and minus 3 over 5 radical 5. So once you factor out radical 5, we end up having 2/5 plus 1 minus 3/5. Then once you calculate this one as a numerator, we end up getting radical 5 times here 4/5. Therefore, 4/5 radical 5 will be our answer. Here we're going to simplify this one. Since our bases are the same, this one will be equal to m to the 4 over 3 power times m to the negative 1/2 power.